Now, our next section deals with the proper inspection, setup, and testing of Oxyfuel equipment. The first step in the correct setup of an Oxyfuel system is to inspect the cylinder valves for damage, as well as for the presence of oils and grease, especially on the oxygen cylinder connections. Next, make sure that the cylinders are properly secured. Visually inspect the regulator connections, hoses, and torch. Also, inspect for nicks or damage to O-rings and other seating surfaces. And be sure that safety devices, such as flashback arresters or reverse flow check valves, are installed in the system. Look around to make sure the area is well ventilated. Next, crack the oxygen cylinder valve to blow out any loose dust or debris. But never direct that oxygen stream toward anyone. After all, that debris could be shot out in the stream and injure someone nearby. If dust or oil is present in the oxygen connection, this too could be very dangerous. That's because the heat that's created by recompressing high purity oxygen in the regulator will cause the dust or oil to burn, and that can result in a regulator burnout or explosion. So always remember to crack the oxygen cylinder valve to make sure it's clean. Next, we're going to go over some basic setup and testing procedures. First, let's attach and tighten the regulator to an acetylene tank. When you attach regulators, be sure to position them at an upward angle. In the unlikely event the adjusting screw were to blow out of the bonnet, then it would be projected up and away from the cylinder. It's important to remember that every type of cylinder gas requires a specific thread or connection. Do not attempt to use regulators designed for one gas on another type of gas cylinder. Notice that the groove on the fuel gas connections indicates a left-hand thread. If acetylene is the chosen fuel gas, be sure that the delivery pressure gauge shows a red line at 15 psi. Before attaching the acetylene regulator, make certain that the cylinder valve connection is clean and free of debris. There are 4 types of acetylene cylinder connections. One of them uses a left-handed connection, and the other 3 use right-handed connections. Larger cylinders containing over 40 cubic feet of gas are designated by the Compressed Gas Association as having 510 and 300 connections. Here you can see a 510. If you look close, you can see the groove that indicates this uses a left-handed thread. And here is a CGA 300. Since there is no groove, this is a right-handed thread. If you are using smaller acetylene cylinders, such as B or MC, the connections are different. These both are designed with right-hand threads. B tanks require a CGA 520 regulator connection, and MC tanks require a CGA 200 regulator connection. Our next step is to attach the hoses. But before you do that, make sure to visually inspect the hose for any damage. Of course, any worn or damaged hoses need to be replaced. Next, make sure that you're using the correct hose for your application. Special T-grade hoses should be used if gases other than acetylene are used. Well, once you've attached the hoses to the regulators, make certain that the torch valves are closed. Then be sure to check the regulator adjusting screws to ensure that they're in the out and off position. Now, let's pressurize the system. It's very important to open the oxygen cylinder valve slowly, allowing the regulator to pressurize gradually. For safety's sake, always stand with the cylinder between you and the regulator. If a regulator explosion occurs, it can explode in any direction, but the least likely direction is toward the inlet pressure. Then continue opening the oxygen cylinder until the valve is fully open. The oxygen cylinder valve should always be turned to the fully open or fully closed position. Never leave it partway. Since all oxygen cylinders are designed with double seating valves, opening one all the way will prevent any cylinder valve leaks of the high pressure oxygen. This will also ensure an unobstructed flow of the gas. Next, turn in the adjusting screw on the regulator to approximately 10 pounds per square inch. Now, open the acetylene cylinder, but only open it about 3/4 of a turn. This will allow a sufficient gas flow for large tips, but at the same time, the cylinder can be quickly and easily shut off in case there's a fire. If the cylinder requires the use of a key or wrench to open, be sure to keep the tool with the cylinder so that it can be shut down quickly in the event of a fire. If you're using an alternate fuel such as propane, it is necessary to open the valve at least a few turns. Now, turn the fuel gas regulator adjusting screw in to 10 pounds per square inch delivery pressure. Leak test all connections by using an approved leak detection solution or oil-free soap and water. If bubbles appear, a leak is indicated. Another method of leak detection after pressurizing the system is to shut down both cylinder valves completely, with torch valves also closed. Then, on both regulators, watch the delivery pressure gauges over time to be sure that there is no pressure drop in the system, which would indicate a leak. If a leak is detected, first identify the location and then tighten the leaking connection if possible. But if it's not possible to stop the leak, then the equipment should be taken out of service immediately and repaired. Once you've determined that the system is leak-free, set the regulator adjusting screws to the appropriate working outlet pressures for the tip being used. And here's a safety tip for you. Every time, before you light the torch, it's important to purge any gas from the hoses. This will eliminate the danger of having mixed gases in the system. To purge the torch, open the fuel valve and let fuel run through the system for a few seconds. Be sure to close the fuel valve on the torch and then repeat the same procedure for the oxygen side of the system. Once you've completed purging the torch, the system is now safe and ready to light.